Hey guys, good morning or good afternoon. This is Mr. Thompson, and we are going to go over the scientific notation assignment that y'all had. Now, scientific notation, I know just by saying that word, a lot of y'all get confused or frustrated, and I understand that. So we're going to get through this as easily as possible so you won't get frustrated. So if you look to the left, you'll see that we have a number like 7,000. The next one is 60,500, 94,000. So all these numbers, we assume that the decimal is at the end of the number, right? It's not anywhere in between. What the goal of scientific notation is you want to get 7,000 into a smaller number. A smaller number kind of that looks like this side more or less. So the first step we're going to do, I'm just going to move the decimal until it hits the last whole number. So for this one, it's going to be 7, and the decimal's there. The second thing, I'm going to count how many spaces I went over. And in this case, I went 1, 2, 3. So it's 7.0 times 10 to the 3. Third thing I'm going to do is I'm going to look at this original number. If it's greater than 1, then this exponent right there is positive. If that would have been less than 1, then that exponent would be a negative. Okay? So let's do another one. I'm going to erase it, clear it up. Once again, the second number, 60,500, the decimal's there. I want to move it 1, 2, 3, 4, right next to that first whole number. So 6.05. If you heard me, I just said I moved it over 4 times. So times 10 to the 4. This number is greater than 1, so that exponent is going to be positive 4. So your answer is 6.05 times 10 to the 4. This tells you that you're moving the decimal over. It shrank. It collapsed this number. Another way of thinking about it. Okay, let's do problem number 3. In this case, we have 94,000. So I'm going to move the decimal 1, 2, 3, 4. So the new number is 9.4. There you go, sorry. And you heard me count out loud, I moved it 4 times. If you look at the original number, it is greater than 1. So with that being said, this exponent will be positive. See? Let's do one that is less than 1. Let's do number 9. Let's do number 9. So here's a decimal. Once again, I want to put it right after the first whole number. So I'm going to move it. I'm going to move that decimal over 1, 2, 3, 4. 3.2 times 10 to the 4. Now this number is less than 1. So since the original number, whole number, is less than 1, this exponent will be negative 4. 3.2 times 10 to the negative 4. See that? Let's do 13 now. Let's do number 13. So number 13 decimal is over here, and you want to get it way over here. So let's count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the new number is 1.0, and I counted 13 spaces over. This number is less than 1. So that number is negative. 1.0 times 10 to the negative 13. See? It's a lot easier than it looks. All you gotta do is move the decimal and count. Let's do one more. Let's do number 17. 17, the decimal is right here, and I want to move it right here. So you could have only one number, once again, one whole number to the left of it, of the decimal. So all I simply have to do is count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. The new number is 3.3 times 10 to the 9. This number is less than 1, therefore the exponent is negative. Negative 9. There. See that? So when you're converting whole numbers to into scientific notation, you're basically just counting how many spaces the decimal is moving over, either to the left, to the right, and if the whole number is greater or less than 0. Hope this helps. The next tutorial will be on how to convert scientific notation into whole numbers.